All right, here we have a horse that's pulling a 490 kilogram carriage with 5,200 newtons of force at a constant speed. So right off the bat, we know that everything is going to be balanced. And let's go ahead and draw the interaction diagram. So we have the carriage, which is being pulled by a horse. Okay, so we'll call this tension force. And they're both on top of the ground. And of course, there's Earth. All right, and so with the horse and carriage, they are standing, they are standing on top of the ground. So that would mean that there is a normal force. But there's also some sort of friction that's happening, okay? So we have also friction that's happening. And then, of course, everything interacts with the Earth. So we are going to pay attention to everything that's going on with the carriage. Okay, we see that there are 1, 2, 3, 4 interactions happening with the carriage. So let's go ahead and draw that. So the carriage will be C, and we see that there is a force of gravity happening on the carriage from the Earth, and that is going to be 490 kilograms. So our force of gravity is going to be 490 kilograms times 10 newtons per kilogram, and that's going to give us 4,900 newtons. All right, and now we have a normal force with the ground. So the ground is pushing up on the carriage, and it's pushing up with 4,900 newtons of force as well. There isn't additional forces acting on the carriage in the up or down direction. Right? And we have this tension force. Now you have to think, in what direction is the horse pulling the carriage? Okay, so the horse is pulling the carriage to the right, and the carriage is pulling the horse to the left. Okay, so we have the tension force here on the carriage from the horse with 5,200 newtons of force. And so then that means our friction is going to be the other direction. So we have the force of friction on the carriage from the ground happening at 5,200 newtons because the forces are balanced. Right? And so that is for that problem.